Hi, it is time to do our solving addition equations, and I think it's maybe a little bit silly that they broke it up this far because I think a lot of you do understand this, but we're just going to take our time and just wander through it. I wanted to show you the picture of the tiles that we're going to use. I don't have actual green tiles, but this is called an X tile and it represents some unknown. So it could be a million and it could be two. We just don't know. So, and this is just one unit. So when we're looking at x plus 2 equals 4, we're going to look at the equal sign and each side being balanced. Like they have to be equal on each side in order for it to work. So I put the x right here. X is an unknown plus 2 units equals this many units. Well, you can see right now from this side to this side that this has to be covering up 2 yellow units. Okay, so that's the picture that I want in your head, is of this balance that has to happen in order to make it work. The other thing that I wanted to show you is you can do x plus 2 minus 2 and 4 minus 2. So subtracting 2 from each side. The way that my teacher liked to show is x plus 2 equals 4. She liked to put the minus 2 right below because it made sense to kids that minus 2 is the same as minus 2. Those two amounts are equal. Whatever you do to this side, it's like having twins. You have to do the exact same thing to the other or there will be sibling mutiny. So when you figure this out, you end up with x equals 2. Any way you write it. This is in a linear way. This is underneath. So you choose the way that makes sense in your brain, and I won't mind. Let's do a couple of these together, and then you can decide if you want to pause me for numbers 3 and 4. So I am just going to do like my teacher taught me right underneath. I know that minus 1 equals minus 1, so I know that x is going to equal 4. I'm going to circle that right down there. So then for number 2, x plus 3, and I'm going to do minus 3 minus 3. You got to do the same thing to both sides, which will get x by itself. And there we go. We got 6. You can try, this one is pretty easy. You can just see that it has to be 0, because if you subtract 4 from each side, you're going to get x equals 0. And then on this side, 7 plus x equals 8. We got to subtract a 7 here, and we got to subtract a 7 there. And then we get 1 equals x. So basically what we're trying to do, we see a variable playing with another number. This is another scenario my other classes have liked. And the variable is not a good friend and cannot play well with others. And so we always are trying to isolate. That variable needs to go to its own room. And the friend needs to go home to their side of the equation. All right, so I want to go through the key concept here. And I want you to identify that a lot of this year we have been talking about when we do the opposite to something. And we're equal, and when we do the opposite to one side and to the other, we added the opposite in our integers. We multiply by the reciprocal or the opposite of the fraction. Here, to solve an addition equation, you need to subtract the same number from each side so that the variable is by itself. And I put it's like a naughty child. You have to isolate that variable and put it in its own room, okay? So I did this one where it's y plus 25 equals 140, and I put the negative 25 or subtracted 25, and I want to really reinforce that we're doing the same thing. Negative 25 is equal to negative 25. So when you do this straight down, you get the 115. What I did when the book asks you to check for it, I substitute back in the y. I put a 115 plus 25 is 140. If that checks out, if this truly is 140, I check it and say, yep, it checks out. So when they say check your answer, that's what they mean. Okay, I have a few for you to try here, and I'm going to pause myself, and I'll put all of my arithmetic down below, and then I want you to look and see if you got the same final answer. All right? All right, so I tried to be very, very clear about my processes, and here P is at 64, Q is 90. I wrote in red what I did across that the equal sign, and I do prefer, you can see my method is going straight down below because it really helps to cancel out or isolate that naughty variable. Hopefully you can see the work. I think a lot of times I see struggles still when kids have to use the zero, so I put my processes up here. I didn't show all the regrouping in these above. Hopefully this is something that's a bit of a review. Please be careful. I'm noticing a lot of arithmetic errors in this class, and it's not because you don't understand how to do stuff like this. What I'm seeing is that it's just a simple mathematical error. Let's cut down on those, okay, everyone? Have a great lesson. Enjoy it. I think algebra is a great amount of fun. It's like a puzzle, and isolate those variables, and maybe we can have a math comic strip with the naughty variables or something like that for those of you creative types out there. Thanks for listening. Have a great lesson.